First one here is to create good data structures for analysis. That might seem so obvious because in the end, you're doing data prep, you're cleaning your data for analysis, and you want to do a good job doing that. But when you create or use a framework or have an actual process down for how you want to clean your data, it'll help you immensely in the long run. Because you'll have expected outcomes after you've cleaned your data. You'll recognize the data to be a certain way, and then you can quickly do analysis based off of that. That sounds a little heady, but I'll show you what I mean here. When I was first getting into data preparation, and this is back when I was using InterWorks a lot. I still use that a lot, by the way. I was just trying to figure out. I was building out all of these data prep pipelines, but I wasn't sure if I was doing it right. I was like, how does everyone else prepare their data? Like, what's the best way to prepare your data for analysis? And I came across tidy data. If anybody knows, if anybody's used R before, the person that created R, Hadley Wickham, he published this concept called tidy data. It's in the Journal of Statistical Software. If you really want to get nerdy about it, there's the link here, and hopefully someone can post that in the chat. But in this, he provides a couple just key principles or things that you would do to make your data tidy. At the beginning of this, he has a couple great quotes, which I really like the way this is framed here. He quotes Tolstoy, and it's the quote, "Happy families are all alike. Every unhappy family is unhappy in its own way." And then he likens that to data, which is like families, tidy data sets are all alike, but every messy data set is messy in its own way. And what this is saying is that data comes to us in so many crazy different messy formats, and we have to deal with it. And it's never messy in the same way. However, if we clean the data in a more standardized way and get it to a form that is useful for analysis, those clean data sets, those tidy data sets, tend to look roughly the same. You'll look at a table that's tidy and you'll be like, that's a good data set for me to analyze. You'll obviously look at a messy one and be like, that looks like a nightmare. So what are those things that we can do to create these tidy or happy data sets? In tidy data, there's three very basic rules. Each variable must have its own column, each observation must have its own row, and each value must have its own cell. And let me dig into that a little bit here. This is just a very basic table that has individual classrooms, the teacher, and then some attributes or dimensions about that, the teacher, room square foot, and then the count of students. When we're thinking about a value is just what's in a cell, right? This is, in this case, count of students. This value here of 20 is 20 students for that classroom. Obviously, and per the rule here, you wouldn't want to have multiple values in the same cell, though I've seen it, but hopefully that one's a little bit more intuitive for everyone here. Each variable must have its own column. So a variable here would be teacher, room square foot, count of students, and the values going down are consistent to that variable. So I'm not, for count of students, I also don't have room square feet also in the same column. And then finally, each observation must have its own row. So our observation here is a room, and we have some attributes about that room going across. So room 101, Miss Frizzle, 500 square feet, 20 students. What we don't have is also in the same row, the values and variables for room 215, right? So this is a very tidy data set. You can do some analysis with this. To kind of hit this home further, this is straight from the paper, but I like these examples. This example here, A, and think of this as maybe results from a clinical trial. We have treatment A and treatment B as columns. The problem here is that treatment itself is a variable, and variables must have their own columns. So what we really need is a column that says treatment, and then in that column as values, we would have A and B. So this is a messy data set. You don't want to analyze this. And then the same goes for this next, this is B. This is also messy. It's basically the same thing, just flipped. We have variables name, which are across columns. They're taking up 3 columns. They should be in 1 column. So the correct way to format this down below is we have name, which is a variable, has its own column. The treatment, which is a variable, has its own column, and the results also have their own column. If you want to dig into this more, again, read that paper, or at least read part of the paper. It was pretty compelling. Anyway, yeah, tidy data set, happy family. Another concept you'll hear especially if you're preparing data for Tableau, you see this mentioned quite a bit, is just narrow versus wide. This is essentially the same idea, but generally your data sets will be a little bit more narrow. Going into Tableau, meaning that you're making your data set longer by the transformation you're doing to clean the data. Data often looks like this first piece here. This is something that you would see coming from an Excel spreadsheet. It's human readable, but not necessarily machine readable. And then thinking back to tidy data, the problem here is that for each column here, there's actually 3 different variables. We have biology, which is a course, and that should have its own column. There's January, which is a time of some sort. That should also have its own column. And then there's students, or count of students, that also should have its own column as well. So we would do something like a pivot. So in your data prep tool, you use the pivot. You probably actually use 2 pivots to work this one out. And you can see down here, we have course and month, and the number of students all in their own column. Again, another way to think about this is this up above, this is human readable. It's easier for our eyes to track, but to do analysis with, for a machine to actually to ingest this information, this top one is not great. The bottom one is much better.